Okay guys, so this is 5.3 linear relationships and bivariate data. So that's your standard, and you're going to be able to contrast linear and nonlinear bivariate data with at least 80% accuracy given independent practice. So we have two vocabulary words here. So bivariate data is basically a set of data made up two pair of variables. So in this case, we usually like using x and y. So that's basically what they're saying. You're using two different variables. And then nonlinear relationships is basically a relationship that creates a non-straight line. So like in this case, and it has a rate of change that is varied. So it's not constant. Okay. So before we get anywhere, actually let me get here. I think this is easiest one to do, and then that way I can erase it and come over here. So in this case, we're going to contrast linear and nonlinear data. So by the way that you see the graph, this is have a parabola. That's basically quadratic equation. You're going to have like x to the second power, okay, modified by other numbers. So in this case, this is a nonlinear because it is not created a straight line. So is it a straight line? The answer on that one is no. So this is not a straight line. And does it have a constant rate of change? And the answer is no. Okay, so in this case, that one doesn't have a constant rate of change. This actually has the constant rate of change is basically a variable. Okay, varies. So make sure that you know that. And then in this case, is this linear? Is this linear data represented here? Yes, it is. It creates a straight line, and yes, it has a constant rate of change. Now, don't get confused with proportional. Proportional has to go through the origin. So this is actually a non-proportional linear, right? Relationship. It is linear because it creates a line, but it's not proportional because it doesn't go through the origin. But it does have a constant rate of change because otherwise it wouldn't create a straight line. Okay, so that's for that. Let me come back over here, and then I'll give you one to do. Well, actually, here, go ahead and tell me. Okay, let me give you one here. Okay, is this linear or non-linear relationship, and is this a linear or non-linear relationship? Okay. Okay, so finding the equation of a linear relationship. So first thing you need to do is find your slope. So I'm given 2 points, so I can call this my x1, y1, yx2, y2. So I'm going to have to go 16 minus 10. And I'm going to go 4 minus 2. Remember to keep the same order, because if you change it, you're going to get it wrong. So 16 minus 10 is 6, and then 4 minus 2, that's 2, and 6 divided by 2 is 3. So that's my slope. So my slope is 3. Okay, so I have that. Okay, that's the easiest thing to do, but then you're going to have to find your b. So you might say, how in the world am I going to do that? How am I going to do that? So you write your equation, and then you basically write, it's like you're investigating, right? So like a spy. So you put the pieces together and you figure out what is unknown by figuring out what you know. So in this case, what you're going to do is, okay, do I know my m? Yes, my slope is 3, right? So I can erase that and I can put my 3 there. Okay, now I don't know my b, but I can get from this 2 points, my x and my y. Now, you can choose whichever one you want. So I'm going to choose this one, and I'll show you that you get the same answer if you choose the second one. Okay? So in this case, my y is 10. I go 3 times what's x2, and then plus b. So then I work this out. So then 3 times 2 is 6 plus b. And so then I subtract this. I remember I have to do inverse operation to isolate my variable. And so that's that. And what I do to one side, I do to the other side. So I subtract 6 on both sides. 10 minus 6 is 4, and that's my b. So my b is 4. So can I write an equation up? Yep. I go y equals 3x plus 4, and I'm done. Okay, let me show you that you get the same answer if you choose this point. So in this point, is the y is 16, and the x is 4, and then I don't know my b. So then you go 16 equals 3 times 4 is 12. And then I do inverse operation here. What I do to one side, I do to the other side. And then 16 minus 12 is 4. So I get the same answer. Doesn't matter what point you choose. Okay? Now, making predictions. So for instance, they might say, okay, is point, let's see, 3, 12 part of this graph. And so what you do is you're gonna plug, you already have your equation here, y equals 3x plus 4, and then you plug in your y and your x value and see both sides are equal. So in this case, my y is 12, so I erase that, put the 12 there, 3, and then that's a 3 right here, and so I solve. So that's 12, so that's 9 plus 4, That's 13. Is 13 the same as 12? No, this is not a point on the line. Okay, let me give you another example. So for instance, if I have 5 comma 19, is that point part of the relationship? Let's see. So I'm gonna do y equals 3x plus 4. I erase my y because that's 19 right here, and then the 5 is the x, so I erase the x and put a 5 there, and I go 19. Is that equal to 3 plus 5? That's 15, and 15 plus 4 is 19. Is 19 equals to 19? Yes. So this point is actually on the graph, okay, on the line. Okay, let me go ahead and give you one to do. Okay, so this one, go ahead and find your slope, and then find your b. Remember, you plug it, you do this for the slope, and then plug in whatever you know using either of those 2 points to find your unknown, which is your b. And then give me the equation y equals mx plus b, but make sure that you write your m and your b. Okay, once you do that, I need you to tell me if this point is part, if these points are part of the equation, and you tell me why yes or no. Okay, so after you found your equation, go ahead and tell me if this point is part of the linear relationship, and if this is part of the line of the graph. Okay, remember, you can do this. You got this. God bless you. Bye bye.